Hi guys, in this video I'm going to go through some of the Unit 2 booklet to help you complete it. So we're on page 15. It says to sketch and label a diagram of how you should set up your equipment for a titration. So you should have drawn something like this, with the main equipment being a clamp stand holding the burette. Whatever's in the burette will drip into the conical flask. You need a white tile under that conical flask in order to see any colour change clearly. Then you might have drawn some extra bits just sat on the bench, like a measuring cylinder, glass pipette, pipette filler, things like that. So if we turn over a couple of pages onto page 17, you'll need a table completed with titration results to 2 decimal places, where the second decimal place has to end in a 0 or a 5. So these are my results, and we keep doing that titration until we get concordant results. So concordant means consistent results that are really close to each other. After we've got those results, we work out an average, only using the good results, and we state our average to 1 decimal place, so we round that to 9.9 centimeters cubed. Then we're asked to calculate the moles of sodium carbonate used, so we do concentration. We made our sodium carbonate standard solution to 0.1 molar times volume. So we use 10 centimeters cubed, and we need to divide that by 1,000 to convert into decimeters cubed to get our answer in moles. Now, using the balanced equation and the moles we've just worked out of the sodium carbonate, we can work out the moles of the acid used. So you can see we've got a 1:2 ratio, because there's no big number in front of the sodium carbonate, but there's a big 2 in front of the acid. So whatever moles we worked out, 0.001 for the sodium carbonate, we just times that by 2 to get the moles of the acid. Here's the average we wrote down earlier from our titration results, from our concordant results. And now we can work out the concentration of the acid from our titration results. So we do moles of acid here divided by volume of acid, so our average, and divide that by 1,000 to convert it into decimeters cubed. So it says something slightly different here. There's 2 ways to do this. I prefer to do the volume divided by 1,000. But they should both give the same answer, which is around 0.200. So this is my value for my results. You should get something close to this. And it has to be to 3 decimal places. Next, we have to work out equipment errors for the pipette and the burette. So we used a 50 ml burette, and the precision, or the uncertainty, in a 50 ml burette is 0.05, and we took 2 readings. So we take that uncertainty value, we times it by the number of readings taken per experiment. So 0.05 times 2 equals 0.1. That's the equipment error of the burette for 1 titration. Then the glass pipettes, they were 10 mils, and a glass pipette of a specific volume has a specific error value associated with it, and I just looked on the equipment to get this. It's 0.02. So that is the amount of uncertainty in the 10 ml pipette. Now we work out the percentage errors using those uncertainty values above. So to get percentage error, we do the error or uncertainty value divided by our reading. So for the titration, we use our average titer, our average volume, and for the pipette, we use the amount we measured, so 10. And we should get a really small number, 1% for the burette, 0.2% for the pipette. And obviously the smaller the number for percentage error, the better that is. Now the total percentage error, all we do here is add up the two errors from these two pieces of equipment and we get 1.2%.